Vectors. We are going to practice O-level maths past exam paper question about vectors from the series October-November 2024 paper 2 variant 1. Let's begin. So October-November 2024 paper 2 variant 1, and the question regarding vectors is question 7, and it contains some coordinate geometry in it as well. The question says ABCD is a parallelogram with sides AB, BC, CD and DA. So the question is talking about a parallelogram whose vertices are A, B, C and D. The question gives the coordinates of the point A that are -3, 7 and the coordinates of point B are 2, 5. And the question gives a vector AD. So the starting point of the vector AD is A and the ending point is D. So the vector AD that starts from point A and goes to point D, the vector AD is -1 and -6. Now in a vector, the top value is the x value. That tells us about the movement in x direction. That means movement to the right or to the left. Movement to the right is positive and movement to the left is negative. And in the vector we are given, the x value is -1. And that means the movement is 1 unit to the left. And the bottom value is the y value. It tells us about the movement in y direction. That means movement upwards or downwards. Upwards movement is positive and downward movement is negative. And in the vector that we are given, the y value is -6. And that means a movement of 6 units downwards. So the vector AD is -1 and -6. And that means if we move from A to D, we go 1 unit to the left and 6 units downwards. So if this is point A, and we have the coordinates of point A in the question -3, 7, and this is point D, and we are not given the coordinates of point D, so let's write x, y. And the question tells us to find the coordinates of point D. Now this is vector AD, starting point at A and ending point at D. If we move from A to D, we go 1 unit to the left and 6 units downwards. That is the vector AD. So if we move 1 unit to the left, that means the x coordinate of point A will decrease by 1, and that will give us the x coordinate of point D. So -3 -1 will give us -4. So the x coordinate decreases by 1 because we move 1 unit to the left. And we move 6 units downwards, and that means the y coordinate of the point A will decrease by 6. So 7 minus 6 will give us the y coordinate of point D, and 7 minus 6 is 1. So because we move 6 units downwards, the y coordinate decreases by 6. And we have the coordinates of point D, -4, 1. And we had to find the coordinates of point D. We can write it in the answer space, -4, 1. Next, the question says find the length of the vector AD. So these two lines mean the length of AD, and that means we have to calculate the distance between A and D. And for the distance between A and D, we need the coordinates of point A that are -3, 7, and the coordinates of point D that we found out in the previous part, -4, 1. And so the distance from A to D, the length of the vector AD will be equal to, using the distance formula, x1 minus x2 whole squared plus y1 minus y2 whole squared, and the square root of this entire thing. Now in place of x1 minus x2, you can also use x2 minus x1, and in place of y1 minus y2, you can also use y2 minus y1. But whatever you use, keep the order same in both the brackets. Now let's say A is point 1 and D is point 2. So the coordinates of point A will be x1 and y1, and the coordinates of point D will be x2 and y2. Now we place these into the equation. So x1 is -3. So in place of x1 we write -3. x2 is -4, and in place of x2 we can write -4. Now remember, there will be two minus signs. This minus sign is included in the formula in the equation, and the other minus sign is with the coordinate. y1 is 7, so in place of y1 we write 7. y2 is 1, in place of y2 we write 1. Now this gives us -3 plus 4 whole squared plus 6 squared and the square root of this entire thing, and that gives us 1 squared plus 36 square root. 1 squared is 1, and that means we get the square root of 37. And if we evaluate it, it is equal to 6.083. And we can write it in the answer space. The length of the vector AD is 6.08 units. In part C, the question tells us to find the vector AC. So if this is point A and this is point C, the vector AC starts at A and goes to C. It moves in the X direction and in the Y direction, and that is what we have to find out. The amount it moves in the X direction will be written over here, and the amount it moves in the Y direction will be written over here. So we have to find the X movement and the Y movement of the vector AC. Now we know the coordinates of point A that are given to us in the question, -3, 7. But we don't know the coordinates of point C, and we have to find the coordinates of point C. Okay, so from the question we have the coordinates of point A, -3, 7, the coordinates of point B, 2, 5, and the coordinates of point D, -4, 1. And we don't have the coordinates of point C, so we write X, Y. So these are the 4 points of the parallelogram that is given to us in the question. And to find vector AC, we need the coordinates of point C. Now let's draw x-axis and y-axis over here and plot these points on the axis. The point A is -3, 7, so it will be over here. The point B is 2, 5, it will be over here. The point D is -4, 1, it will be over here. And we don't know the coordinates of point C, but the question says ABCD is a parallelogram. And that means the point C will be in such a place that ABCD forms a parallelogram. So that means point C should be somewhere over here so that ABCD can make a parallelogram. And in a parallelogram, opposite sides are parallel. And that means this side AD will be parallel to BC. So the sides AD and BC will be parallel sides, and that means the vector AD will be parallel to the vector BC. And these two vectors will be equal to each other because they are parallel and they are equal in length. And we are given the vector AD in the question. The vector AD is -1 and -6. So that means AD is -1 and -6. And because AD is parallel to BC, BC will also be equal to -1 and -6. Let me explain to you why. So this is point A and this is point D. And the vector AD goes from point A to D. And when it goes from point A to D, it moves 1 unit to the left. That is what -1 means. And it moves 6 units downwards. And that is what -6 means. And for the vector BC, this is point B and this is point C. And the vector BC goes from point B to point C. And because this is parallel to the vector AD, it will also move 1 unit to the left and 6 units downwards. So it will also be -1 and -6. So the vectors of the opposite sides of a parallelogram are equal to each other because they are equal in length and are parallel, and that means the vector BC will be equal to -1 and -6. So this is point B and this is point C, and the vector BC is this vector. So the vector from B to C goes 1 unit to the left, -1, and 6 units downwards, -6. When it moves 1 unit to the left, the x coordinate of point B will decrease by 1. So 2 minus 1 will give us the x coordinate of point C, and that will be equal to 1. And when it moves 6 units downwards, the y coordinate of the point B will decrease by 6 units. So 5 minus 6 will give us the y coordinate of point C, and that will be equal to -1. Now we have the coordinates of point C and we have the coordinates of point A, so we can find the vector AC. The vector AC will have an x value and a y value, and we need these values. So the x coordinate of point A is -3 and the x coordinate of point C is 1. So if we draw the x-axis, the x coordinate of point A is over here at -3 and the x coordinate of point C is over here at 1. And if we move from A to C, we move 1, 2, 3 and 4 units to the right. That means +4. So the x value of this vector will be +4. And if I draw the y-axis, the y coordinate of point A is over here at 7 and the y coordinate of point C is over here at -1. And when we move from A to C, we move 1, 2, 3, 4, 5, 6, 7 and 8 units downwards. That means -8. So the y value of this vector is -8. And this is the vector AC, 4 and -8. In the next part, part D, the question says, line L is the line perpendicular to AB that passes through the point D. Find the equation of the line L. Now the equation of a straight line is in the form y equals mx plus c. And in this equation, m is the gradient of the line and c is the y-intercept of the line. First, let's calculate the gradient of the line. So, gradient of the line L. Now the question tells us that line L is perpendicular to AB. And from coordinate geometry, you should know the concept about gradients of perpendicular lines. Now let's say L1 and L2 are two straight lines and they are perpendicular to each other. And let's say the gradient of the line L1 is -4. And we need to know the gradient of the line L2. We should know that the gradients of perpendicular lines are negative reciprocals of each other. Now what that means is that if one line has a negative gradient, the other line perpendicular to it will have a positive gradient. So the gradient of line L2 will be positive. And reciprocal means if the gradient of one line is 4, the gradient of the other line will be the reciprocal of it, that is 1/4. Now let's use another example. Let's say the gradient of line L1 is 3/4. So the gradient of the line L2 that is perpendicular to it will be the negative reciprocal. Gradient of line L1 is positive. So the gradient of the line L2 will be negative. And the gradient of the line L1 is 3/4. So the gradient of the other line that is perpendicular to it will be the reciprocal 4/3. So the gradients of perpendicular lines are negative reciprocals of each other. So line L is perpendicular to AB. That means if we have the gradient of AB, we can use that to calculate the gradient of line L. So let's find out the gradient of AB. In the question we are given the coordinates of point A, that is -3, 7 and the coordinates of point B, 2, 5. This is the information given to us in the question. So to calculate the gradient m of the line AB, we use the equation for the gradient y1 minus y2 divided by x1 minus x2. Now you can also use y2 minus y1 divided by x2 minus x1 and the answer will be the same. All you need to do is keep y1 above x1 and y2 above x2. So this will be 7 minus 5 divided by -3 minus 2 and that will be 2 divided by -5 and so the gradient of AB will be -2/5. Now we can find the gradient of the line L. Line L is perpendicular to AB. So the gradient of line L will be the negative reciprocal of the gradient of AB. So we will first change the sign. Gradient of AB is negative, so the gradient of line L will be positive. And for reciprocal, the gradient of AB is 2/5, so the gradient of line L will be the reciprocal of that 5/2. And so we have the gradient of line L 5/2. Now for the equation of the line y equals mx plus c, we have m, the gradient, that is 5/2, and so the equation is y equals 5/2x plus c. And now we need to calculate the value of c. And to do that, we need a point on this line. Now the question tells us that the line L passes through the point D, and the coordinates of point D are -4, 1. And so the x coordinate of point D, -4, can be placed into the equation in place of x. And the y coordinate of point D, 1, can be placed into the equation in place of y. And we get 1 equals 5/2 times -4 plus c. Now 2 is in the denominator and 4 is in the numerator. So we can simplify these. 2 1s are 2, 2 2s are 4. And we get 1 equals 5 times -2 plus c. 5 times -2 is -10. And this gives the value of c as 1 plus 10. And so c is equal to 11. So in the equation of the line L, we have both m, the gradient of the line, and c, the y-intercept. So the gradient is 5/2 and the y-intercept is 11. So the equation of the line is y equals 5/2x plus 11. And we can write it in the answer space, y equals 5/2x plus 11.